Now, good morning, students. Yesterday we have done the Venn diagram and also the complement of the sets. Now, let us see here the practical application of the sets operation. I hope you have must write the question of exercise 1.5 that are based upon the complement of a set and the Venn diagram also. Let us consider now the practical application of set operations. Now here let us see the results. If A and B are disjoint sets, then the number of A union B is equal to number of A plus number of B. The result is here, if A and B are two disjoint sets, then the number of A union B is equal to number of A plus number of B. And the second, the most important result is here, if A and B are two finite sets, then the number of A union B equal to number of A plus number of B minus number of A intersection B. Let us see how. This is the Venn diagram of what? A union B. Then the number of A union B equal to number of A plus number of B minus number of A intersection, because when we are counting number of A and number of B, this portion has been counted twice. Therefore, the number of A union B equal to number of A plus number of B minus number of A intersection B. Now, let us see the other result. When A, B and C are finite set, three finite sets are given, then the result is the number of A union B union C is equal to number of A plus number of B plus number of C minus number of A intersection B minus number of B intersection C minus number of A intersection C plus number of A intersection B intersection C, means the common elements in A, B and C. See the result again. The number of A union B union C equal to number of A plus number of B plus number of C minus number of A intersection B minus number of B intersection C minus number of A intersection C plus number of A intersection B intersection C. Now, the one more thing I am going to tell you. This result, number of A union B, can also be written as with the help of this diagram. Let us see. The number of A union B can also be written as number of A minus B plus number of A intersection B plus number of B minus A. Again, see it here. A union B is the whole portion. It can be written as number of A minus B plus number of A intersection B plus number of B minus A. It depends upon our question. Either we are using this result or we are using this result. In the 80% question, we are generally using this result. The number of A union B equal to number of A plus number of B minus number of A intersection B. When the three sets are given, then you are using this result. Now here the number of A dash union B dash. Now A dash union B dash can be written as what? A dash union B dash can be written as A intersection B dash. This we have learned in the De Morgan's law, because we know A intersection B dash is equal to what? A dash union B dash. So therefore the number of A dash union B dash is equal to what? Now we have to find out its complement. It means it is what? Number of elements in U minus number of elements in the intersection. Therefore, number of A dash union B dash can be written as number of U minus number of A intersection B. Similarly, the number of A dash intersection B dash. Now, A dash intersection B dash can be written as A union B dash. So, therefore, A dash intersection B dash, the number of A dash intersection B dash can be written as number of U minus number of A union B. Now, mainly these two results are generally we have to use in the question. These results may rarely used to make our question easier sometimes. And the other result already I have explained. The number of A union B can be written as number of A minus B plus number of A intersection B plus number of B minus A. These are the results that we have to apply in the practical problem depending upon the set. Let us see the questions. Now let us see here the question. The very first question is very simple question. If A and B are two sets such that number of A equal to 17, number of B is equal to 23 and number of A union B is given to be 38, then we have to find out the number of A intersection B. Now we know that number of A union B is equal to, because it has been asked in the question, you have to find out A intersection B. It means A and B are not disjoint set. So therefore, number of A union B is equal to number of A plus number of B minus number of A intersection B. So putting all the values given in the question, we are getting the value of what? Number of A intersection B equal to, just doing the calculation, we are getting this is equal to 2. Let us see another question. Now here the number of A is given, number of B is given, number of A intersection B is given, and number of union is given 700. Find n number of A dash intersection B dash. It means the elements neither in A nor in B. We have to find out the elements neither in A nor in B dash. Now we know that A dash intersection B dash can be written as A union B dash. Now here how to do it? We have to find out number of A dash intersection B dash. And previous in the result also we have written that the number of A dash intersection B dash. It means elements neither in A nor in B, because you have to given number of union equal to 700. It means there are some elements which are neither in A neither in B. Then always the number of union is number of element in the universal set is always given. Now the number of A dash intersection B dash can be written as number of U minus number of A union B. So therefore number of U as it is. Now we know number of A union B equal to number of A plus number of B minus number of A intersection B. Putting all the values you are getting here, this is equal to 300. It means there are 300 elements which are neither in A nor in B. So therefore this gives us the value of what? Number of A dash intersection B dash. So number of union minus number of A union B. Now let us see another question. Generally the question are explained like this. In a committee, 50 speaks French, 20 speaks Spanish, and 10 speak both Spanish and French language. How many speak at least one of these two languages? At least means we have to find out union. In a committee, 50 speak French, 20 speak Spanish, 10 speak both Spanish and French. How many speak at least one of these two languages? When the word at least is there, it means we have to find out A union B. Now let us first we have to write down, let A be the set of the people speaking French. We always suppose let A be the set of people speaking French and B be the set of the people speaking Spanish. Now it is given that number of A is 50, number of B is 20 and number of A intersection B it is given to be 10. So we can write here the number of A union B. We know number of A plus number of B minus number of A intersection B. Then putting all the values you are getting here what? 60. Therefore there are 60 people speaking at least one of these languages. Whenever the word problem is there, always to have to express your answer in the word in the last. I have understood this question. The question is here 50 speak French, 20 speak Spanish and 10 speak both Spanish and French. How many speak at least one of these two languages? First, the meaning of at least or either A or B. So therefore it means we have to find out the union of A and B. We can assume one set as A be the set of the people speaking French, B be the set of the people speaking Spanish. Now the number of A is given, number of B is given, number of A intersection B is given. So we can easily find out number of A union B equal to number of A plus number of B minus number of A intersection B. Putting all these values we are getting here, the number of A union B equal to 16. Now let us see another question. The question is here, in a group of 400 people, 250 speak English only and 70 can speak Hindi only. You have to find out these quantities. First, the word is here English only. Now suppose let A be the set of the people speaking English and B be the set of people speaking Hindi. Then 250 speak English means the number of A minus B. And similarly, the number of 70 can speak Hindi means the number of B minus A, it is given to be 70. See it again. The total there are 400 people are there. 250 speak English only and 70 can speak Hindi only one. You have to find out how many can speak both English and Hindi. Now here we first assume let A be the set of the people speaking English and B be the set of the people speaking Hindi. So therefore it is 250 means the number of A minus B because this is A only. This is what? B only. It means this is given to be 250. This is given to be 70. So therefore we have to find out the how many can speak both Hindi and English. Now from the Venn diagram it is very much clear. This is 250, this is 70 and total student people are given to be 400. So therefore the answer of the first part will be what? We have to find out how many can speak both English and Hindi. It means we have to find out A intersection B. So total it is what? 400. 400 minus 250 plus 70. So it is what? 80. Similarly, how many can speak English? Now we know this intersection is 80. This intersection is what? 80. Now how many can speak English? So it means we have to find out the total people which are there in A. So it will be 250 plus 80. So similarly, it is number of A is 250 plus 80, 330, very much clear from the Venn diagram. Similarly, the number of people speaking Hindi means the number of B is what? 70 plus 80, that is equal to 150. This is how we can use the Venn diagram to give the answer of these questions. Sometimes the Venn diagram are very much helpful to do the practical problems on the sets. Either you can use the relation number of A union B equal to number of this, or you can use the Venn diagram, which is more convenient to you. You can use for the solution. So this is all about today. Now based upon this you can easily try the question of exercise 1.6, the word problem or the practical problem depending upon the set theory. Now in the homework you have to do the question of exercise 1.6. Next time we will do these operation or the word problem depending on the three sets where we have to use the number of A union B union C result we will use in further question when we have to give a three sets A, B and C. This is all about today. Have a nice day.